Let's now take a look at that concerted mechanism, the one-step elimination reaction. So again, here's the overall reaction. Recall that this is a beta elimination, since we're eliminating the proton at the beta position from the leaving group. And we are going to get an alkene product as well as some byproducts. And here's what the mechanism looks like if it occurs in one step, the concerted reaction. So you have proton removal occurring at the same time as pi bond formation and leaving group displacement. And once again, you get the alkene product. Here's the energy profile for this type of reaction. It's just one step, so there's one activation energy barrier to overcome. And so again, we're interested at this transition state at the top of the hill, because anything that we do that will help to lower this transition state energy will make the reaction go faster. So since the rate determining step, the only step of the reaction, does involve both the alkyl halide and the base, we say that it's exhibiting bimolecular kinetics. Recall that these each have an exponent of 1 there that's not shown, and it's the sum of those that the molecularity comes from. It's an elimination reaction, and so this is given the designation the E2 reaction. So here's the transition state for the E2 reaction. If you could snap a picture of what was going on at the top of the activation energy barrier, it would look something like this. And there are a few key features of this transition state that we need to discuss. The first of those is the developing pi bond. And the second of those is the fact that the base itself is in the transition state, so it is deprotonating at the beta position. Also note that the leaving group and the base are situated in a very specific manner. I have drawn this intentionally where they are anti to one another. Hopefully you remember that term from when we looked at Newman projections, but they have a 180-degree dihedral angle and they lie within the same plane. And so we say that the E2 reaction is going to require an anti-periplanar geometry.